Welcome to our video on antiderivatives and getting started with everything that is antiderivative. So what's important to know here is that we've been taking derivatives of things, okay? Going through and through and through. Now we want to take a step backwards, and that's called an antiderivative. If we take the opposite of a derivative on something, okay? So right here you can kind of read what the process of it is. Really what happens here is it's really a specific thing here taking antiderivatives. Really, here are all the formulas that you're going to need to know for antiderivatives. If you look on the one side, it's taking derivatives, and on the other side, it's just going to be the antiderivative, and then these go hand in hand. All right, these are all opposites of each other. So you do need to memorize all of these formulas and all of these formulas. Okay, so there's no two ways about it, but if you do understand the derivative part of it, then you'll be fine. The big one for today especially is going to be this one, is like reverse power rule. Okay, so if you have x to the r, all you're going to do is you're going to add to that number, and you're going to divide by that same number you just added to for those. Okay, so that's a big one. Also, if you notice, all of these have a plus c. Plus c just stands for just a constant, because again, the derivative of a constant is 0. So then antiderivative of anything is going to now produce a constant. Okay? So the whole idea here is if you take the derivative of the right side, you'll get the original on the left side. So if we take the derivative of, for instance, of sine, right? Take the derivative of sine. Well, where is it? No, right here. Okay. Take the derivative of sine, get cosine. Take the antiderivative of cosine, is going to give you a sign right there. So plus a constant. All right. You take the derivative of this right here. Take the derivative of sine plus c. You're going to get cosine, which is going to be produced right there. So let's just get to doing some problems. All right. So again, for antiderivatives, or these are also known as integrals. If you see this symbol right here, that's an integral symbol. Vocabulary-wise, either one is good. So if you want to take the antiderivative of this function right here, you actually need to distribute this all the way through, because we don't know how to do this. This is not one of our rules. If you look through all of our list of rules here, it's not going to appear one of these guys. So what we do need to do is we need to make this into something that we do know how to do. So 2x times x is going to give me an 2x squared. 2x times 3 is plus 6x. 2x, negative 1 times x is negative x, and we're going to get minus 3 dx. If I rewrite that so it looks nicer, 2x squared plus 5x minus 3 dx. Now I just set this up now, so now it's a bunch of those reverse power rules. Okay, so how this is going to work is we're going to add 1, so it's going to give me x to the third, and we're going to divide by that number now, so over 3, and that coefficient still in front is a 2. Plus, we're going to add 1, so we're going to get x squared over 2. We still have that 5 in front right there. Minus, and then the antiderivative, just a constant, is just going to be 3x, which is super nice. And then plus my c value. Okay, so these are all a bunch of power rules. Now this kind of looks a little ugly, so let's just rewrite it so it doesn't look so bad. And that is what you're going to get. Right there. Okay? So we can also do this by solving for our constant as well, because sometimes we'll be given information that will help us find our constant. So for instance, we're going to go with this one right here. So it says solve the differentiation equation, but it gives us some ideas what our constants could be. Okay? So to find f prime, I'm going to go ahead and take the integral of f double prime, which is cosine of x dx. Well, what is the antiderivative of cosine of x dx? It's actually going to be sine of x plus c. Again, if you didn't know that, it is right here on our little formula chart. Okay, so you kind of notice before for derivatives, all the c's became negative. And now it's more or less kind of sort of like the opposite here. Okay, so if you take the antiderivative of the cosine, it's going to be a plus. Take the antiderivative of a sine, that becomes a negative. Doesn't really hold true when we start to get a little bit lower, but for the basic two, sine and cosine, those just flipped a little bit. Okay, so this is going to be f prime of x. Now I can find that constant value because I know if I plug in a 0, I'm going to get 3. So I'm going to go ahead and do that right now. So if I do f prime of 0, which equals sine of 0 plus c, this is going to give me a 3. So 3 equals sine of 0. You got to know that that's 0. So it's 0 plus c, which is c. So now this produces an equation of f prime of x is equal to sine of x plus c. Okay, and we can actually keep going. We'll take the antiderivative of that because I can keep going to find the original because I know all this information. So now to get the original, f of x, I'm going to take the, why did I write plus c right here? Silly me, this should be a plus 3. I don't know if I can change that c into a 3 very well. Should be a 3. All right, sorry for getting back on that one. So this is going to be sine of x plus 3 dx. Okay, so again, taking the antiderivative of these, so f of x is going to equal negative cosine x plus 3x. And what am I given here? Oh, I almost forgot something. I ran out of room, that's kind of probably why. Plus my constant value. Now I'm ready to plug in a 0 into my original. So f of 0 is equal to negative cosine of 0 plus 3 times 0 plus c. F of 0 is negative 2. Equals cosine of 0 is 1, so negative 1 plus c. Now we're going to add that 1 to both sides here. And we're going to get c to equal negative 1. So my final answer is going to be f of x is equal to this negative cosine x plus 3x minus 1. And there you go. So if you were to take the derivative of this twice, you will end up with just plain old cosine. All right, let's start applying this to some of the PVA stuff, the position, velocity, acceleration ideas here. So we have a particle that moves along an x-axis at a velocity. So we have the velocity, and then at time 2, we have its position being 3. Let's find the acceleration. Now, this is not new for us because if you take the derivative of velocity, you get acceleration. So this is not so bad. Just take the derivative of this. So v prime of t is going to give you my a of t, which is 12t squared minus 6t plus 0, and that's it. Nothing else. Just double check. So we're good. All right, that's the acceleration function. Now to find the position function, x of t, you need to take the derivative of, antiderivative of v of t. So it gives me the integral of v of t dt, which is going to be the integral of 4t cubed minus 3t squared plus 5. And this is all going to be dt. And again, it's dt because everything's with respect to t here. Okay? So this is going to give me, well, add 1 to that 3. You're going to get to the 4th. Divided by that, you're actually going to end up with t to the 4th. Minus, you're actually going to end up with t to the 3rd here. Plus 5t plus c. And this is my position function. Now, it is going to tell us here that we can find more information because we have at 2, the position is at 3. So when I plug in a 2, we get 2 to the 4th minus 2 to the 3rd plus 5 times 2 plus c, and that's going to end up equaling 2. So if you do all this math here, I'm going to kind of take a bit of a cheat here. I'm going to go, oh, this should be equal 3. Why did I say equals 2? Well, not a great video for me. It should equals 3. I can't read directions. Okay. If I go on this side over here, I'm going to get 18 plus c equals this 3. So C is going to end up equaling negative 15. So my final answer for x of t is going to be x of t equals this t to the fourth minus t to the third plus 5t minus 15. And there you go. All right, and then the last one's just finding f. So this one doesn't give us any initial conditions, so we'll just have some some constants in there when we do our antiderivative. So let's go for it. So f prime of x is going to equal the integral from 1 plus x to the 4/5 dx. And this is where it gets tricky, is these fractions, okay? So first one, antiderivative of just 1 is going to be x plus, now we have to divide, so we have to add 1 and then divide by that number. So this is going to be x to add 1 plus 4/5 is 9/5, and divide that by 9/5 plus c. Let's clean up what this looks like a little bit. It's going to equal x. Since you're dividing, you're actually just flipping the bottom and multiplying. So it looks like this, plus c. Okay, so this fraction gets a little tough. Now to find f of x, we're going to take the integral of this x plus 5/9 x to the 9/5 plus c dx. So here we go. So we're going to add 1 here, which gives us x squared. Divide by that, so 1/2 x squared plus, this one I'm just going to go slow. So if I add 1, I'm going to get 14/5. So I'm dividing by 14/5. I'll fix that in a second. Plus c times x, plus another constant. You can do like c1 or k or whatever. I'm just going to go to the next letter in the alphabet and go d. All right, let's clean this up a little bit. This is going to give me a 1/2 x squared. I'm going to end up flipping this and multiplying. So it's going to give me 25 over, I'm going to use my little cheat sheet over here, 25 over 126 x to the 14/5 plus cx plus d, and there's nothing else that you can do with this. All right, and that is all.